The Royal Observatory of Belgium has been diving into the mysteries of the sun for over a century. With their cutting-edge telescopes, they gather tons of data on solar activity, helping us unlock the secrets of solar dynamics. How cool is that? And speaking of cool missions, the Solar Orbiter is on a quest to predict space weather, which can seriously mess with high-tech stuff on Earth like GPS and power grids. Being in the know about solar activity is key to staying prepared for anything that comes our way. But wait, it gets even more fascinating. Scientists are cracking the code on why the sun's corona is way hotter than its surface. This ongoing research might just reveal some of the biggest mysteries we've faced about our sun. The probe's unique elliptical orbit lets it make multiple close approaches to the sun, gathering invaluable data on solar activity. These close encounters are essential for giving scientists the insights they need to understand solar phenomena like never before. One of the major goals? To study the solar corona, which remains one of the biggest mysteries of the sun's atmosphere. Getting a grip on this area is crucial for understanding solar winds and how they affect everything in our solar system. And guess what? The mission has even uncovered a dust-free zone near the sun. This revelation is shaking up our understanding of space debris behavior, which could have major implications for how planets and other celestial bodies are formed. We can't forget about the moon. It stands as a massive frontier for exploration, with only a tiny fraction explored by humans. Can you believe the last manned missions were over 50 years ago? It's clearly time for a fresh dive into lunar adventures.
Boom.
The Artemis mission is here, and it's bringing some seriously innovative technologies to the table. With the European Service Module and NASA's Orion capsule, astronaut safety is a top priority, showcasing teamwork across Europe that's out of this world. On top of that, we're gearing up for robotic missions like the Viper rover, set to scout potential landing sites for future manned missions. These robots will help us uncover lunar resources, especially water, which is key to sustaining human life on the moon. Even cooler, the immersive control station lets astronauts get hands-on with the robotic arm, allowing feedback just like they're on the lunar surface. This kind of technology is a game changer for operational efficiency during space missions. But that's just the beginning. The complexity of the experiment involves lots of players and objectives working together to validate new technologies in environments similar to the moon. Teamwork like this helps fine-tune our operational skills for future missions. To prepare even further, robotic systems are being tested in real-life scenarios right here on Earth, like on the slopes of Mount Etna. This simulation of lunar conditions gives us a heads-up on astronaut-robot interactions and boosts our robotic capabilities. Switching gears to oceanic missions, the dual-frequency radar altimeter on Sentinel-6 is a superhero for measuring ocean surface height, wave height, and wind speed. This tech is a game-changer for marine operations. And let's talk about climate change. Satellite data is a crucial tool for understanding long-term climate trends, helping scientists track the effects of human activities on our environment over decades. It's all about action and awareness. Glacier melting isn't just for science fiction anymore, it's contributing significantly to sea level rise. We're witnessing a dramatic acceleration due to climate change, and the effects are being felt across the globe. Coastal regions like Bangladesh and Venice are on the front lines, facing severe flooding risks from rising sea levels and storm surges. These places highlight the immediate dangers of climate change, reminding us why action is necessary. And guess what? Monitoring ice melt and sea level rise is absolutely vital for understanding our climate's dynamics. Space observations provide essential data that helps inform policy decisions on climate action. But it's not all doom and gloom. Simple actions like reducing water usage and cutting down pollution can make a big difference in preserving our environment. Awareness and recycling practices are steps we can all take towards sustainability. Zooming in on Venus, radar mapping has revealed its rugged surface, complete with mountains and volcanoes, all while peeling away its dense atmosphere. The heat there is so intense that it can melt lead.
Wow.
Missions like the Parker Solar Probe are revealing thermal emissions and surface features of Venus, showing us that extreme heat exists even on the night side of the planet. It's like a planetary spotlight. Looking ahead, Future missions like NASA's Veritas and Da Vinci are set to explore Venus's atmosphere and geology. They'll focus on understanding its past habitability, which could be a game changer in our search for life. And here's some exciting news. Telescopes can now detect vital molecules like methane and carbon dioxide, which are critical for finding planets that might support life. This is a massive leap forward in exoplanet research. Understanding the atmospheres of smaller rocky planets is key, as they represent the perfect spots for potential habitats for life. Researchers are zeroing in on Earth-sized planets around sun-like stars. Talk about cosmic ambition. Exploring extreme exoplanets with unique atmospheric conditions expands our understanding of diverse planetary environments. This knowledge is vital as we search for habitable worlds beyond our solar system. The ISS, or International Space Station, is a treasure trove for scientific discoveries. It lets scientists study how gravity and microgravity affect human biology and technology over long periods. This research is essential for preparing for missions to Mars and beyond. And guess what? A new robotic arm has been added to the ISS, boosting operational capabilities. This arm can handle payloads on its own, making tasks during missions way more efficient. Talk about futuristic tech. Here's something interesting. Astronauts experience changes in taste and even crave more salt in space, which can lead to bone loss. This draws a fascinating link between our dietary habits and health in microgravity. Who knew space could be so complex? The Dream Chaser is a game-changing vehicle designed to be launched on rockets like the Vulcan Centaur. It's set to transport both cargo and eventually crew to the orbital reef, with a payload capacity of up to 5,000 kilograms. Now, that's what I call heavy lifting. But hold up. Space debris is a massive threat to both satellites and manned missions, with thousands of fragments still orbiting Earth. Remember the 2009 satellite collision? It shows just how serious this issue has become. So, what's the solution? Innovative ideas for tackling space debris include using robotic spacecraft to capture larger objects and safely deorbit them. These efforts aim to reduce the risks linked to the surge of commercial space activities. Juno's unique polar orbit allows it to map Jupiter's surface and really dive deep into analyzing polar regions more effectively than any mission before. This approach supercharges our understanding of the planet's atmospheric dynamics. And check this out. Juno utilizes advanced solar technology that's super important for operating in Jupiter's low-energy environment. Thanks to these innovations, Juno performs effectively even amidst intense radiation levels. Juno's discoveries might just help us confirm theories about Jupiter's formation as the first planet in our solar system. These findings offer clues about the primordial dust and gas that created it. Understanding this composition is crucial for grasping planetary evolution. Let's rewind back to Voyager 2, the only spacecraft that has ever visited Uranus. It revealed the planet's featureless atmosphere and its wild weather patterns, including winds reaching speeds of up to 250 meters per second. Talk about extreme conditions. Uranus's magnetosphere is also a head-scratcher, being tilted and asymmetrical, which causes auroras to pop up far away from the poles. This unusual orientation massively influences the planet's magnetic field and atmospheric dynamics. But what's next for Uranus? Future mission proposals are buzzing with ideas, including using nuclear and solar-powered probes, with ion propulsion being a top choice for efficiency. However, it's important to note that budget constraints mean no missions are currently funded or scheduled. And speaking of fascinating worlds, Jupiter's tidal forces generate heat and friction within Europa, sustaining its mysterious subsurface ocean. This geophysical activity is super important for conditions that could potentially support life. The upcoming Europa Clipper mission is set to take things to the next level, gathering extensive data through multiple flybys. With advanced instruments on board, it'll dig deep into Europa's surface and search for possible water plumes. By understanding Europa's ocean, we might reveal secrets about the origin of life elsewhere in the solar system. This mission could clarify whether life arose independently from Earth's biological history. Can you imagine the possibilities? The Titan-Saturn system mission is all about groundbreaking planetary exploration and showcasing methods never seen before. It underscores the importance of continuity in our understanding of space exploration knowledge. Did you know Uranus has 27 known moons? Some of its major moons, like Miranda and Titania, show geological activity, including volcanism and unique surface features. This indicates a dynamic and exciting history. Neptune's moon Triton stands out with its retrograde orbit and atmosphere, giving us a glimpse into the early solar system and the dynamics of celestial bodies. It's like unlocking a chapter of cosmic history. Satellites like the Advanced Composition Explorer are on the lookout, studying solar wind and energetic particles to better understand the effects of solar storms on Earth. Their insights help us predict space weather events that could impact our lives. The Solar Dynamics Observatory is like a photojournalist for the sun, providing high-definition imagery that lets scientists observe solar phenomena like sunspots and solar flares in stunning detail. It's a visual treat. And let's not forget about coronal mass ejections. These powerful bursts can disrupt Earth's magnetic field, leading to breathtaking displays of auroras. Those energetic particles create stunning visual phenomena at the poles. NASA's MMS mission is on a quest to explore magnetic reconnection and its effects on the magnetosphere using a constellation of 4 spacecraft flying close together. This mission deepens our understanding of plasma interactions in space. Did you know that magnetic explosions from reconnection processes can trigger significant weather patterns in space? This impacts communication satellites and power grids right here on Earth. The more we understand, the better we can predict. Looking ahead, future space missions from various agencies, including those from Japan and India, promise to enhance our understanding of solar phenomena and improve real-time monitoring of solar wind. These advancements are crucial for delivering accurate space weather alerts. Spitzer's infrared capabilities have led to remarkable discoveries, including hot Jupiters and other unique planetary types, expanding our knowledge of diverse planetary atmospheres and compositions. The universe just keeps getting more exciting. Kepler's mission involving 165,000 stars has unearthed over 2,300 planetary candidates, showcasing an incredible variety of planetary systems and potential habitable zones. We're truly living in an age of discovery. And let's hear it for Kepler 186f, the very first Earth-sized planet found in a habitable zone. This discovery marks a major leap in our hunt for life beyond our solar system. It's a true milestone. The 30M telescope in Hawaii is gearing up to be a game-changer in observational capabilities with its innovative primary mirror design. This beauty will consist of 492 hexagonal mirrors working in harmony. Can you say amazing? And there's more. The European Extremely Large Telescope, boasting a 39M diameter mirror, is on track to become the largest telescope ever built. Its completion is expected in 2024, and it will enhance atmospheric studies of exoplanets. Exciting developments continue with various space-based telescopes, like the James Webb Telescope, being crafted to replace Hubble and elevate our understanding of the universe. These missions will allow us to observe the cosmos like never before. Check this out. Herbig-Haro objects form when supersonic jets from newborn stars eject matter into surrounding areas, showcasing the dynamic processes of star formation. These jets are so cool to see change over time. Thanks to Spitzer's infrared capabilities, astronomers can see through dust and uncover stellar nurseries where stars are born. This has sparked thousands of published papers highlighting new discoveries. It's like an astronomy explosion. The James Webb Telescope is set to revolutionize our understanding of star formation with its larger mirror and cutting-edge technology. It aims to detect those hidden young stars tucked away in gas and dust. Imagine the possibilities. But that's not all. The expansion of the universe is closely tied to an increase in dark energy, contrasting with the dilution of ordinary matter. This dynamic is shifting the balance of dark energy over time. It's a cosmic dance. And here's a mind-blowing fact. Weakly interacting massive particles, or WIMPs, are considered the leading candidates for dark matter. They glide through the universe with minimal interaction, making their annihilation events rare yet crucial for understanding dark matter. Looking ahead, future missions, like gravitational wave observatories, will enhance our grasp of cosmic phenomena. These exciting advancements may reveal even more about dark matter and the very structure of our universe.